Okay guys, so during my last video on the formula, the various formulas for calculating the normalized difference index, I promised I'll make videos on the various indexes. So today we are looking at a modified normalized water index, and that is MNDWI. So to calculate the MNDWI, you need band 3 and 6 in terms of using Landsat 8 and 9. So on my previous videos, I showed how you can download Landsat data from Earth Explorer. So you can quickly refer to that. I'll share the link and look at how to download that. And from there, you can kickstart with analysis. So to do this, we will need our Landsat data. So I have downloaded mine and I saved it as child. So I need these two bands, band 3 and band 6. Okay, so I have my two bands loaded. So I'm just going to edit this for the sake of visibility. I don't want to struggle to see which is band 3. So this is band 3, B3, and band 6. Okay, so band 6. Okay, so what we're going to do is we are going to do the analysis. So we can do this by going to go to your app toolbox. So in your app toolbox, yeah, my laptop is running quite slow today. Okay, so you open up your app toolbox, then we go to spatial analysis. So from spatial analysis, we have quite a number of things. Okay, so spatial analysis tool, you have from conditional to zonal, surface. But what we're going to use is, this is a raster data. Okay, so we want to calculate, just do some ratio, and because of that, we need something related to algebra. So we'll go for map algebra, then you double click on raster calculator. Okay, so it pops up. This is what comes up. Okay, and you see both data, both bands here. So what we're going to use is we're going to use the float. Okay, so you scroll here, search for float. Okay, where is my float? Yeah, here we go. So the float is here. You double click. Now the formula for calculating MNDWI is, so let me just quickly do that. So the formula is band 3. So yeah, band 3 minus band 6 divided by band 3 plus band 6. So float, then you select your band 3 minus band 6 divided by float again, and band 3 plus band 6. Okay, so when you're done with this, you would browse to indicate where you want to save your file. Okay, so I hope this is transparent. Okay, so you navigate to where you want to save the work. So I was actually using trial, so that is what I'm going to select. Trial folder, so I have it here, and I'll just give it some name. So let me say MNDWI. Sorry, I mostly work with NDWI, that's the normalized difference vegetation index, so I'm mostly used it. So .TIF, okay, TIF. Now we are good to go. So it's running. We can actually check the progress as I always do. So you go to geoprocessing, and from geoprocessing you can go to the results. I think it's kind of running slow. That's just my problem now. I have to work on that. Pardon me for the slowness. So results, this guide to like be given this way. So you can just open that up. Environments, no any error. So we're waiting for the message. Okay, so the output can be negative or positive depending on what you enter. Okay, but it hardly happens to be negative. Okay, so we're just waiting for it to run. Sometimes when you want to download, okay, so this once I downloaded, I think I didn't indicate the cloud content, the cloud cover, so I downloaded an image that is full of clouds. Okay, the cloud cover is so all these are clouds, and the dangerous thing is it's going to maybe indicate this to be maybe it might classify this as something, but that may not be the case. It may give it a color that it prefers, but the cloud sometimes causes a lot of things, so it can make the analysis look weird. But when you are downloading it, you should make sure you look at the cloud cover and you change it. Maybe, presumably, I mostly take cloud cover of less than 3. But it's sometimes difficult to get Landsat data that is cloud free, but you get that for some years, but some years you may not get that at all. So if that is also an issue, then you try using Sentinel. Okay, so there are different ways to do that. Okay, so now we have our work. We have after running it, this is what we have. Okay, so let's do the color notation. Then so this is water body. Let's do our quick. It's related to water, so I'll go for this. Interesting. So what it is saying is we have the highest. So the higher, areas that are above 0 are water bodies and has high content of water. Like those areas indicate, so high content of water. Then, so it gives just a clear picture of how the place is like. But because of the okay, so that's it. This is actually a root, so it got that right. Okay, but so I was talking about clouds. Okay, so because all the clouds have been classified as kind of water bodies, as I said. So most times when you are getting the data, you should make sure you get a cloud-free image. Otherwise, all of it is classified as water bodies. So basically, that's how you calculate. So you should get the formula right, and you go through the process, and you have everything done correctly. Okay, so if you have a study area, you clip that out. Okay, just clip your study area out, and you are good to go. So I have videos on how to clip out the study areas. You can refer to that, and that will be great. I hope this helps you in your work. All the best, and bye-bye.